Have you ever really stopped to think about what a kilogram actually is? Or a second? I mean, these units are so baked into our daily lives that we barely even notice them, but they are part of this incredible, invisible system that, honestly, allows our entire modern world to function. So let's pull back the curtain a little and explore this hidden language that we use to describe our physical universe.
To really get why this all matters, let's just start with a simple question. How far is a stone's throw? I mean, really? Or how about a hop, skip, and a jump? The thing is, these measurements completely depend on who's doing the throwing or the hopping, right? They're vague, they're inconsistent, and if you need to do anything serious, they're pretty much useless. This is the heart of the problem: ambiguity.
There's this great line that just hits the nail on the head. Distances given in unknown units are maddeningly useless. Without some kind of shared, standardized system, measurements are just meaningless numbers. Can you imagine trying to build a smartphone or launch a satellite if one engineer's inch was different from another's? No way. It would be absolute chaos.
And historically, this was a massive problem. Every town, every trade, they all had their own local units. It led to so much confusion and, chaos. What the world desperately needed was one single, universal language for measurement that everybody, everywhere, could agree on.
And that solution? Well, that's the International System of Units, or as pretty much everyone calls it, SI. It's the modern, globally agreed-upon version of the metric system, and it was designed specifically to bring order and clarity to all that chaos. It's the standard for scientists, engineers, and really for almost every country on Earth.
And you can just see the pure elegance of the SI system right here. Everything is based on powers of 10. A kilometer is 1,000 meters. Easy. A centimeter is 1/100th of a meter. Simple. Now compare that to the English system, where 1 mile is 5,280 feet and a foot is 12 inches. That beautiful simplicity is exactly why SI is the official language of science.
Okay, so how does this whole universal language actually work? Well, it's built on a foundation that is, frankly, just beautiful in its simplicity. It turns out that every single physical thing we can measure, from the speed of a car to the brightness of a distant star, can be described using a combination of just 7 fundamental units. That's it, just 7. These are called the base units. And I think the best way to think of them is like the Lego bricks of the physical world. They are the absolute fundamentals, the core building blocks that you can combine and rearrange to build every other measurement you could possibly need. And here they are, the magnificent 7. You've got the meter for length, the kilogram for mass, the second for time, and 4 others. It's such a powerful idea. These 7 units are the complete alphabet for the language of physics. From just these, we can spell out literally everything else. So, if the base units are the Lego bricks, how do we actually start snapping them together to build something new? Well, this is where we get into what are called derived units. And it's so beautifully straightforward. You just take a base unit, let's say the meter. You can combine it with itself, so meter times meter, and boom, you've just created a brand new derived unit. Area, measured in square meters. You've built something new from the fundamental pieces. The real power of this system is in all the combinations. You combine length in meters with time in seconds, and you get speed. You combine mass in kilograms with volume in cubic meters, and you get density. Every single measurement is just a different combination of those original 7 base units. It's amazing. But, just defining these units is only half the story. The other half is this fascinating human story, this relentless quest for more and more precision. Because the more accurately we can define our base units, the more powerful our technology can become. I mean, just look at the meter. It started as a fraction of the size of the Earth. Then, for a long time, it was literally a physical metal bar locked in a vault in Paris. But here's the thing about physical objects. They can change. So scientists redefined it based on something that is truly constant, the wavelength of light, and eventually the speed of light itself, a fundamental constant of the universe. The second has a very similar story. It's not a fraction of a day anymore, because it turns out the Earth's rotation isn't perfectly stable. It wobbles a bit. So today, 1 second is officially defined as the time it takes for a cesium atom to vibrate, get this, over 9 billion times. Atomic clocks measure these vibrations with an accuracy so insane they'd only lose 1 second every 100 million years. And look, this obsessive quest for precision isn't just some academic exercise. It has very real consequences for all of us. That incredible level of accuracy in how we define time is exactly what allows the GPS satellites orbiting the Earth to pinpoint your location. Without those atomic clocks, your phone's map would be totally useless. And here's the perfect example of why this matters so much. Until very recently, I'm talking 2019,
The official kilogram was a literal cylinder of metal. And the problem? Over a century, scientists figured out it had lost about 50 micrograms of mass. So, in 2019, they finally redefined it. It's not tied to a physical object anymore, but to a fundamental, unchanging constant of nature called the Planck constant.
Okay, so let's just recap the big ideas here. We've got the SI system, which is this amazing universal language for measurement that brings order to chaos. Then, we learn that this entire language is built from just 7 core building blocks, the base units. And finally, our relentless quest to define those units with more and more precision is what actually makes so much of our modern tech possible.
You know, when you think about it, it's a pretty profound thought. Our entire complex physical reality can be described with this simple, elegant system of just 7 fundamental units. It really leaves you wondering, what other parts of our universe, from biology to maybe even society, might also be governed by a set of surprisingly simple fundamental rules just waiting for us to discover them?